We're good? Welcome everyone for today's session on SageMaker and how to enable SageMaker in a highly regulated environment. Myself, Ritesh Shah, work for Vanguard Group as a senior program manager for enabling AI and machine learning services. You want to
go? My name is Pham. I'm the lead cloud engineer for the Cloud Alex services at Vanguard.
So to start with, let's start with the agenda for today, right? We are going to go high level first with SageMaker, an overview of it, some of the key requirements that we had, and then we start going deeper into how did we enable SageMaker, reference architectures and designs, how did we secure it, etc. And some challenges and solutions that you can take away. Before we go deeper into SageMaker, right? Quick question, how many of you know Vanguard here? Okay, 50%. A quick Vanguard intro slide, right? We are one of the top mutual fund companies in US. Our core purpose is to take a stand for investor and help them save for their long-term retirement and other goals. Let's start with another question. How many of you know what SageMaker is? Okay, 70% of the people know, but quick intro, SageMaker, a managed service that offers full machine learning capabilities for everybody to use. You can build, train, and deploy your models that you build using SageMaker, and you can deploy it as endpoints that can be called through microservices, or you can run it as batch mode as a model. It also comes with optimized frameworks and algorithms that run on AWS infrastructure efficiently. And last but not least, you can bring your own machine learning models and algorithms if you don't see that the optimized ones don't work for your use case. Next section is a typical lifecycle in Amazon SageMaker, right, if you use it. And why am I talking about lifecycle when this is a security conference, right? The most important thing I think we want to share with all of you is most data scientists and machine learning engineers work in a production environment. They don't work like a typical developer or an engineer where they have a development environment and then they have a test environment where they test and then they deploy something to production. They typically work right in production with production data. That is their development environment. And then how do you securely enable that capability is why lifecycle in SageMaker is very important. First piece of the lifecycle is you build a machine learning algorithm or a model that meets your use case. And to build that, you basically use a Jupyter notebook, you bring in your own models, or you bring in or utilize the ones provided by SageMaker. And also the same notebook interface helps you prepare the data for the model while you're working in a production environment. Next is once you do the build of a model, which is your development activity, you train the model so that you know the outcomes that it has to achieve are achieved using algorithms that you're using. And there are different techniques that people use to train their model, like hyperparameter tuning, etc. Once you train the model, you want to validate your model, make sure the model yields the outcomes that you are looking for. And if you're happy with it, that's where your development lifecycle ends as a typical data scientist, where now you're ready to say, my model is ready to be put in production either as an endpoint or I can run it in batch mode every other day And if it is an endpoint, it can start taking traffic from other microservices or web applications. Which brings to the final phase where you deploy the model into production, and it provides you that capability. And at Vanguard, we want the data scientists to perform all these activities themselves with minimum IT intervention, which is why explaining this typical life cycle in SageMaker is important, because it's the end business teams utilizing the service to make everything function. Before we went down that path, we had some key requirements that we wanted to ensure are met. First is, anytime you have a data scientist working in production environment, we want them to work with data that is encrypted at rest, and while they are building their model or training in transit, it's encrypted. That was a requirement. Next requirement was, we don't want data scientists to access public internet, download algorithms that are not thoroughly gone through a governance process at Vanguard. So we wanted to block access to general internet when they are using SageMaker as a machine learning service. All actions, which is the third requirement, of all actions that the user performs either during build or train or validation of the model needs to be audited, so that if we perform an internal audit and ask ourselves a question, who trained this model or who built this model that got hosted on a website, we should be able to track it all back, saying this is the user who did the building, and then this is the user who trained the model. Next, when we deploy the model into production as endpoints or batch, we wanted to use CI/CD based deployments, so that data scientist doesn't have to work or navigate through IT processes to get something into production. It should be as simple as push a button and their model gets elevated to production when they want to. Next requirement, like I said earlier, we wanted to minimize IT support needed so that business can self-provision. And if we meet all these 5 requirements, we wanted to also make sure that SageMaker service is easy to use, so that data scientists don't get a tool that has met all these requirements but is unusable by them. Next, I want to go at a 25K feet level of how did we enable SageMaker across this entire life cycle, and Hung is going to go deeper into each of these sections of the life cycle and go through some security and other concepts. First piece, like I said, we have data scientists who work in production and actually build and code and develop their model in production. So that's the first phase where we enabled a Jupyter notebook through AWS's service catalog interface, where data scientists can go in and spin up their own SageMaker notebook instance to write their algorithm. And we provision them data, and we provision them access using IAM roles. And these notebooks are pre-configured to use any algorithms that AWS provides, or data scientists can build their own Docker images and bring their own algorithm and deploy it to ECR. Next phase, like I said, we want data scientists to use everything, so we enabled the same notebook interface as a mechanism to train their model. We could have taken a different path where we could have said, hey, data scientist, you go to AWS console and then set up a training job. But we did not do that, because the moment you do that, you would lose audit tracking of who ran what job at some point in time. So we locked them into the notebook and allow them to do training using the notebook, which leads to the next phase of validating the model, where we leverage the same notebook through which they spin up a batch, SageMaker batch mechanism, and they validate their model using the data set they want to validate the model with. At this point, their development lifecycle ends, and then the data scientist takes various artifacts from the validation phase, uploads it to code repositories like Artifactory and Bitbucket. And at times, he also uploads, if they bring in a custom algorithm, he or she would upload a Docker image file into a code repository. Post which, we have set up an automated Bamboo-based deployment process that would allow the data scientists to take the model or the artifacts that they have checked in, and they can then deploy the same model to a development environment, a test environment, and eventually they will deploy it to production environment using a full CI/CD cycle where there's automated testing done, and it also opens automated change records to audit track deployments of artifacts to production. This is where we end the high-level 25K journey, but Hung's going to go deeper into each phase of the life cycle. Yeah.
So the user is a data scientist. So what we focus on is how to make the self-service capability and how make it very easy to use for data scientists. So what we found out is Service Catalog can provide all of this core functionality. It's very easy to log into AWS console to launch and to terminate Service Catalog for SageMaker Notebook. The user can do it as a self-service on demand without contacting any IT team to provision the infrastructure. The other thing is the Service Catalog can provide the standardization of the configurations. The default behavior, if the user want to create SageMaker Notebook, they have to provide a lot of information like VPC configurations, KMS key, internet access. Service Catalog can provide automation of all of this component and also provide an abstraction layer of all the security configurations. In addition, we don't have to provide the security configuration for infrastructure for the users. Instead, we provide the security to the IAM Service Catalog role. During this project, right, we was able to implement the authentications, authorizations, and auditability, and I'm going to go over the detail of that in the next couple of slides. The beginning of the SageMaker implementation, we didn't have the Git integration for SageMaker. So what we did is we integrate SageMaker Notebook into the S3. Right now, we're actually in process of migrate that over the code commit to allow the user to save and share and version control the notebook. By default, the SageMaker also have a lot of Python library and machine learning library inside the SageMaker servers. However, there is a certain use case that the data scientists require additional Python library. So what we did is we integrate with Vanguard managed Anaconda repository. So here's the architecture diagram for SageMaker build service. Before the user can launch a service catalog for SageMaker Notebook, there is a one-time initial setup by the IT team. For example, they have to create the IAM role for the console access, the SageMaker Notebook execution role, the training job execution role, the S3 bucket, and service catalog product and portfolio. Once all of that infrastructure is set up, the data scientists can log into our internal application for Active Directory credential for authentications. They can start launching their service catalog product. And the SageMaker Notebook actually live in SageMaker VPC, which is in AWS managed service account. So as a part of the automation of the service catalog product, in our CloudFormation, we enforce a lot of standard security configurations. For example, we disable internet access for the notebook. We create the notebook and map it to Vanguard managed VPCs. What it means is behind the scene, SageMaker create the ENI for all the communications between the notebook have to go to Vanguard VPCs. For example, on the diagram, if the SageMaker notebook want to talk to our S3 bucket, the SageMaker notebook has to go to the ENI and go to our Vanguard VPC S3 endpoint to be able to talk to S3 bucket. There are two types of S3 bucket on the diagram. The first one is the user workspace S3 bucket, which allows the user, the data scientist, to bring their own data into and to do explore, clean, and transform the data. That's their experimentation area. The second S3 bucket is a master data area, meaning the SageMaker notebook can only have a read-only access to this S3 bucket. This is our gold copy and very tightly controlled. The data in this master data area is typically bring into the ingestion process. For example, you have an EMR cluster try to ingest data in and transform the data and store the data in this master data area. So next, we also enforce the encryption address for S3 and EBS volume using server-side encryption's customer managed key. One thing to keep in mind for EBS encryption is the encryption for EBS only applicable to the machine learning storage volume. In SageMaker notebook, there is a root volume. The root volume is only encrypted using the default server-side encryptions. So what we tell our data scientists, anything you perform action in the notebook, typically you save the data in S3 bucket, or if you want to save data locally, you need to store data in the machine learning storage volume. With the new recent release feature by Amazon, we also disable root access into the SageMaker notebook as well. So now the user is able to authenticate themselves to create the notebook. The next step is authorizations. So by default, when the user tries to log into the notebook, the user is SageMaker authorize the user based on the IAM role. With a specific SageMaker permission, create three-sided notebook instant URL permissions. However, the authorization is at the IAM role level. From Vanguard requirement perspective, we have auditability requirement that we have to track the user ID, the user actions, and S3 object. So to solve the problem, what we did is we create a single tenant SageMaker notebook servers. There's two reasons for that. The first one is for auditability, meaning if you have a single tenant, only single user in the notebook, it's easier to implement the auditability. The second reason is it's allow easier for user experience. Since it's very simple to create the service catalog product on demand for data scientists, we don't see the reason why they need to share the notebook with any other people in the teams. So with that requirement, we want to be able to implement the authorization at the user ID level. So what we did is we create the IAM tagging conditions to solve the problem. So when the service catalog product tried to launch the SageMaker notebook, what we did is we create a Lambda functions to be able to obtain the tagging condition of the service catalog product with containing the user ID who launched the product and insert that tagging condition into the SageMaker notebook tags. We create, on the screen right now, we create a principal tag with the format of role ID : user ID. That's on the right-hand side. On the left-hand side, we have a customer managed IAM policies, which using resource tags of the principal with the value of AWS : user ID. The reason for that is the AWS : user ID variable for federated login user ID has the same format of the principal tag that we created. By doing so, we enforce the user authorization, meaning the user who launched Service Catalog product only that user can log into the notebook itself. For example, you have a user A and user B in the same IAM role. User A can log into that notebook, but user B cannot log into that notebook at all. There is a second IAM conditions on the screen as well, is the IP address. The reason for that is we want to enforce only Vanguard internal network can access this notebook. For example, if the user, even the user copy the access key and secret key into their home laptop at home, they cannot log into SageMaker notebook. So next thing is auditability. Like we talked before, right, we want to be able to track the user ID and user action and S3 object. By default, the IAM permissions only track the IAM role level in CloudTrail event only. So to solve that problem, what we did is we modified the Jupyter server configurations, and we create an environment variable called AWS execution env environment variable for SageMaker server process. That's what you see on the screen. And the value for that environment variable is all the tag in the SageMaker notebook, which also containing the principal tag, which containing the user ID. Here's an example in the CloudTrail event. We have the event name is a get object. We have a bucket name. We track out the S3 object key. We also have the SageMaker notebook execution role in the CloudTrail event. That's a very typical CloudTrail event. But the important thing on that screen is we have a user agent. That user agent also containing the value of the AWS execution environment variable that we defined in previous configurations. And that has all the tagging conditions, and also contain the principal tag with the user ID in it. So at this point, we should be able to track the user ID, the S3 actions, and S3 object. So at this point, the user is able to create the SageMaker notebook to be able to log into SageMaker notebook. The next step is they want to create a training job. So in order to create a training job, they need to specify the data in S3 bucket and with the algorithm in ECRs. So for building algorithm and supported framework, the algorithm image is stored in ECR that is managed in AWS Managed Service account. So for the easy experience, we allowed users to create this training job right from the SageMaker notebook. They can use Bodo 3 and the SDK, and in the API, they can specify the instance type, number of instance, the KMS key, the VPC configurations. So SageMaker training job can create the infrastructure, train the data, and save the model artifact in S3 bucket. The challenge here is we don't have a service catalog product to enforce security configurations like we did with the notebook. So to solve the problem, what we did is we create the CloudWatch, we use the CloudWatch event and the Lambda function to do the security enforcement for us. So here's the key enforcement that we did with the Lambda functions. We enforce the encryption address for S3 and EBS volume using the server-side encryption CMK, customer managed key. We also enforce encryption for multi-node training for intercommunications. We also enforce that there is no internet access by making sure that the user create a training job using our VPC configuration like subnet and security group. Besides the Lambda function enforcement, we're also using the IAM role to enforce authorizations, meaning the notebook execution role can only create a training job with the specific training job execution role. We don't want the user to bind to any arbitrary IAM role. So there is a couple of challenges with the training job, right? The first thing is we have a auditability gap as we speak today, right? We're actively working with SageMaker product team today to figure out how to resolve the auditability for the training job. We actually reviewed the design with the SageMaker product team, and they actually in process of deliver that fix for us. The second challenge is the user experience. Even the user can create the training job API in the notebook, but they still have to specify the IAM role, the VPC configurations. From a data scientist perspective, is a non-value added, right? They don't want to know about the infrastructure. So that we also provide the feedback to the SageMaker product team to solve the problem long term. So at this point, right, the data scientists will be able to create a training job with the model artifact is stored in S3 bucket. The data scientists want to be able to evaluate that model artifact. What we did is we use a SageMaker batch transform for the model evaluations. The user would have to go to transform the data, create a training job, evaluate the model to multiple iterations. Eventually, they found the model based on the metric that meet the requirement. They need to elevate that model to the hosting endpoint. So here's our process for the SageMaker deploy. The important thing is, up to this point, everything the data scientists do is that model development process. Now, we call this process is they want to deploy that model into productions. We call it operationalization process. The hosting endpoint is going to be consumed by client application in productions. So it is true production applications. It's just like any other microservice applications. So in order to do that, we have to follow the standard development lifecycle deployment process. However, the user in this case is a data scientist. They're not IT team. So in order to make that easier for the users, what we did is that we simplified the deployment pipeline. We create a single repository for containing all our infrastructure code, meaning all the cloud formations, to create a SageMaker endpoint configurations, and SageMaker model. And the data scientist would not need to know about any of this configuration, doesn't need to know about any of this infrastructure component. That Bitbucket repository is managed by centralized infrastructure team. The second repository on the screen is a data scientist managed repository. They only need to modify a couple of the parameters that we predefined for them. For example, the SageMaker model name, the URL, the endpoint configurations, and the traffic distributions. It's really very simple parameters. When they submit that to that process, they submit it for peer review and approval process, just like a standard normal SDLC process. We also create a template for the build plan and deployment plan, so their scientist doesn't have to worry about the pipeline. We're going to make it very simple for them to use. The build plan, what it does behind the scene is it merges the parameter of the data scientist managed repository and with our infrastructure repository, and the model artifact in Artifactory. And that merged artifact is going to be deployed to the deployment plan. The deployment plan is going to deploy that into engineer, test, and production environment. We're actually in process right now of implementing the CI/CD for this process. It's currently out of scope of these presentations. But the whole point of the idea of CI/CD is during the build process, we should be able to create the SageMaker endpoint dynamically and create a framework to submit inference into that SageMaker endpoint and compare the output, match the expectation by a data scientist, and if that output is matched, the build is passed. That's our long-term vision of CI/CD, and we plan to roll that out. So now the deployment plan can deploy the engineer, test, and productions. In the endpoint, there's the endpoint configurations and also containing the production variants. In the production variants, it containing the model and the traffic distributions. So on the screen, for example, the first elevations, the data scientists deployed the variant 1, model 1 with 100% traffic distributions. And after that, the data scientists do more experimentations and actually modify the code, create a new model based on new version of the model or new algorithm for that endpoint. The second deployment is going to contain variant 2 and model 2, and they have the ability to modify the traffic distributions. For example, the current model 1 has a 90% traffic distributions, and model 2 has a 10% traffic distributions. And they can model metrics and log to determine the model 2 has expected behavior. After that, they can decide to cut over 100% of the traffic distributions. That's to allow blue-green deployment support. So at this point, the data scientist is able to deploy SageMaker endpoint. The client applications can start submit inference into SageMaker endpoint. And it only needs to have an IAM role with permission of invoke endpoint permissions. For example, the application could be in EC2, EMR, or Lambda functions. We also created the Amazon SageMaker runtime endpoint so that the inference doesn't go over the internet. We also allow the SageMaker notebook to submit inference into SageMaker endpoint for validation during the deployment process. The next one is the custom algorithm. So up to this point, we talk about the training job, the batch transform job, the hosting endpoint. All of that process doesn't change with custom algorithm. The only difference is for the built-in algorithm and the supported framework, the algorithm image is stored into AWS managed ECR. For custom algorithm, the Docker container is developed and created by data scientists. And they're going to push that into Vanguard AWS account managed ECR. That's the only difference. So there's still like two processes. The first process is Docker image development process. So a data scientist needs to be able to create and customize the Docker image. In order to do that, they need to be able to have a starting base image to build it from. So what we did is we create a Vanguard Amazon SageMaker Docker base image. That image also supports a common library and have a standard configurations. For example, it supports Python, R, and have an integration with Anaconda to bring in additional library. We also install the standard library like GUnicorn, Nginx, or Plumber. Those libraries allow to serve the model. So from that base image, the data scientist can use Jupyter Terminal to do Docker pull, do the conda install, to write that custom config, custom code, and do a Docker build and Docker push right from the notebook. When they push into ECR, what we did is we create two separate types of ECR repository. The first type is the team repository for experimentation area, meaning during the development process, the data scientists need to push the image and delete the image and do two multiple iterations of it. So that's their experimentation area. Once they decide that Docker image in ECR is what they expect it to be, and the way they do that is they can create a training job, the batch transform job to validate that Docker image. So once they have that validated Docker image, they want to operationalize that image. So just like same concept with operationalization of the hosting endpoint, they have to go to the SDRC process for the Docker image as well. So now they have to copy that Docker file, the custom algorithm code, put into Bitbucket, go to their review process. And we're also creating the template for Bamboo build plan and deployment plan. And the Bamboo build plan can build that order file, build the Docker image, and push it out to test, engineer, and production ECR repository. So here's a couple of key takeaways from our project. When we start out the project, right, you need to have a clear requirement from both business, from the user experience, and also the security requirements. What we find out is the AWS Service Catalog can provide you a very good self-service capability. We actually use that for SageMaker Notebook, but we also use that for EMR, and actually our long-term direction is self-service enablement for a lot of our infrastructure. AWS Lambda is very good for enforcement. During the presentation, right, I talk a lot about the development process and also the operationalization process. The output of the development process is going to be the input for operationalization process to be able to elevate that into production environment. But the issue here is, the challenge here is, how do you integrate the development process to the operationalization process seamlessly and make the user experience to be easy for data scientists? Even now for us, it's still a challenge, and we plan to solve that problem long term. The other thing is, we want to focus on client experience. During our project, we partner with our data scientists and get continuous feedback from them. And that is a very useful process and multiple iterations to fix it. And that has keep continue going. Lastly, we develop a close relationship with the SageMaker product team and also professional services. A lot of what you saw in our diagram, we actually have a lot of bug fix and feature requests to SageMaker product team. I think that's it. Thank you for coming. Hope that helps.